Okay, so here are our classic polar curves, and the limniscus, pretty sure you're not going to be responsible for those, but thought I'd at least introduce them to you. Spirals of Archimedes, there's no way you're responsible for those, but I left those on here because I also wanted you to notice that that equation doesn't even have a sine or cosine in it. But the way it spirals out is whether theta is positive or negative. But these other three columns are definitely fair game. Do you have to know absolutely everything that we talked about yesterday, all the properties, the names, and everything? And the answer is no. Okay. I think the more that you're exposed to, the better you will know the stuff that you need to know, though. And so I'm going to show you quickly again these curves. All right. And without looking at your paper, I want you to tell me, if I have a circle like that, would that be a cosine graph or a sine graph? Cosine, because it's on the x-axis, right? Which is not really the x-axis, it's really the polar axis. I feel like I keep needing to say that. It's fine that we talk about it as x and y because it's what makes sense to us, but just know that they don't really exist there. All right, and then that's what a sine one would look like, right? And both of them being positive. And then we have our, without looking at your paper, can you remember what category this is at least? Limison. Okay, it's a limison. And if you don't know the names, it's okay. But that's a limison with an inner loop. That would be cosine, right? There's your cardioid, which would be negative sine, right? And your dimpled limison that looks like he kind of wants to be a cardioid but didn't quite make it, or he was a cardioid and then he gained some weight or something, I don't know. And then your, what's that one? What kind of limison? We can look at paper. Convex. It's convex limison. And it's convex because really this one is concave, right? And then it's kind of like it fills up with more air. It's kind of like a wonky circle. All right. And then the flower, or I keep saying flowers, the roses. This would be sine or cosine? Cosine. Would this one be sine or cosine? Sine. I have nothing on the y-axis, but remember for the roses, it's either on the x-axis or it's not. That's how you know if it's cosine or not. So that one is sine, that one is cosine, okay? And yesterday, before fifth period, I'm standing in the hallway talking to Mr. Ackerman, and he, I guess he's starting polar with BC yesterday because he said, all right, what should I expect the kids to know? And I was like, well, what do you expect them to remember cold? Since it's been literally a year, because that's what we're doing right now. They probably don't just remember, but I said it should sound familiar and you can remind them. He said, well, I need them to know if, especially with roses, if it's sine or cosine. I also need them to know how many petals it would have. And if they can know those two things, then we can move on, and that'll get us through so and so and so. So those two basic things, and remember your number of petals has to do with that n number. If it's odd, like this one's 3, that's the number of petals. If it's even, then you have double the number of petals. And so that's what we need to know. We don't have to be able to graph it. We don't have to necessarily even know that. I mean, this one you kind of need to know it's a rose because you talk about the petals, but the other fancy names, not necessary. Just a general understanding. And you will have enough of an understanding to get through the multiple choice questions you need on here and to do what you need to do in calculus, whether you're taking BC or eventually take Cal 2, that sort of thing. All right, so let's look at one of these examples then. This says, when working with multiple choice questions involving polar functions, it's advantageous, there's your $5 word of the day, to evaluate a function at several values of theta, okay, using multiple choice options. So it's not really like this is a trick on how to like plug the answers in or anything. You still have to have an understanding of what's going on, but you don't have to understand it so deeply that you have to answer it from scratch since it's multiple choice. All right, does that make sense? So I'm going to show you what you need to know, how we can work through these. So when we're looking at this one, okay, so it says the same wording we talked about yesterday. The figure shows the graph of the polar function r equals f of theta, which is the same as saying like y equals f of x, for 0 to 2 pi. Okay, and that actually might change. Now, if it changes and we're solving, it matters, and we have to pay attention. If this said from 0 to pi, it wouldn't change anything you do. All it's telling you is what they used to plot this function for you. okay? And then I'm going to address that again once we look at the other graph. In the polar coordinate system, which of the following could be an expression for f of theta? All right, so when you look at this graph, right now, you should be able to eliminate some answer choices. Look at your answer choices, look at your graph. What can we eliminate? C and D. Why? Because it's not cosine, exactly. So now, even if you had to guess, you have a 50-50 shot, right? You just increased your chances of getting the right answer, but hopefully we don't have to guess, right? So then I'm going to pick a point because it said evaluate at several points. And sometimes it may not have to be several. Sometimes it is because it'll work in more than one thing. But I'm going to pick this point right here, okay? And because I can see there that the radius, the R value is 3. What is that angle right there? Pi 6, okay? So what I want to do is I want to substitute in pi 6 down here and see which one of these will give me 3. If they both give me 3, which is a possibility when you do this, then I need to pick another point and try another one, okay? So when I substitute this pi 6 in here, I have to multiply it by 3 because it's 3 theta, right? So I'm going to go ahead and figure out what 3 theta is. That's going to be 3 times pi 6, and what's that going to give me? Pi what? Halves. So really, I'm evaluating at pi halves. Makes sense? Instead of me multiplying each time. Okay, so I'm going to have 3 times the sine of pi halves. What is the sine of pi halves? 1. So this just gives me 3. So I go to pi 6, 3. That's what I expected. That's what I wanted. I like A. I still need to check B. So then this is going to give me -3 times the sine of pi halves. Well, sine of pi halves is still 1. So this is -3. And when I go to pi 6, not pi halves, pi 6, so that's my actual angle. That's why I wrote that down, so I'd use the right thing. Pi 6 and go to -3, I'd end up over here, and that wouldn't work. But think about this. If this was a 4-petal rose, it would work because I'd have symmetry on the rose, right? And then I'd have to try a different one. Okay? But this one does not work. I don't end up on my rose, so my answer is A. Everybody good so far? Any questions? All right. So this one is also going on page 104 when we're done. All right. Can anybody tell me what this is called? Limmason with what? An inner loop. Yeah. And there's no such thing as a limmason with an outer loop. So it's just really a limmason with a loop, I guess, when you get right down to it. All right. So the wording exactly the same as the last question. So look at the graph. Look at your answer choices. Go ahead and see if you can eliminate anything. Without having to do any work, right? Anybody brave enough to tell me they think they know what the answer is? What? B, okay. So anybody else agree with that? So first of all, do we think this is sine or cosine? Sine, right? And so I can eliminate those two again. Is it positive sine or negative sine? Negative sine. So my answer is B. So just knowing that much, we could have got that question right. Now, will all the questions be that easy? No. Could I have a question exactly like this that has more answer choices that I couldn't eliminate? Yes. So let's go ahead and talk through this and see what we would have to do otherwise. So let's pretend like now, if you've already marked yours out, you don't have to erase yours. I'm going to erase mine just because we're going to start over, but you're totally fine to leave yours because I'm just going to end up with that back there again. Okay. So I'm going to pick a point. Let's pick this point. Well, that helps if I had a pen. Let's pick this point right here. So that point, that radius is 6, and the angle is what? 3 pi halves. All right. And here, it's just theta. I'm not multiplying. So here I have 2 plus 4 times the sine of 3 pi halves. What is the sine of 3 pi halves? -1. So that's going to give me 2 minus 4, which is a -2. So if I go to 3 pi halves at this angle and I go to -2, I end up right there. That is not on my graph, so I don't like it. All right. So this will be 2 minus 4 times the sine of 3 pi halves. Sine of 3 pi halves is still -1. -1 times -4, that would be 2 plus 4, and that gives me 6. And that was actually the one I wrote down, so I like B. But that doesn't mean that these other two might not also work. I mean, I know we know now that they don't, but let's just pretend like either we didn't know or it was written some other way. So I want to substitute the same thing in. 2 plus 4 times the cosine of 3 pi halves. What is the cosine of 3 pi halves? 0, right? So 0 times 4 is 0. I just get 2. So look what happens. I'm going to go to 3 pi halves, this angle, and go to 2. That's on my graph. You see that? So right now, I don't hate C. All right, let's go ahead and look at D. So I'm going to get 2 minus 4 times the cosine of 3 pi halves. Well, that's still 0. So this is still 2. Well, if I didn't hate C, I don't hate D right now either. Okay, we're good with that? So you have a couple of options here. I could pick another angle, like I could pick pi 6 right here, or I could pick a -2. Either way, this is not pi 6. I'm sorry, it's a pi 6 angle is what I meant. And because it's on, I can see what, I'm pretty sure that's right at 4. Like I at least get close enough. So let's just do that one. Or we can do this one over here. Okay, which one y'all want to do? Does it matter? It don't matter. We'll do the 11 pi 6. This is at 11 pi 6, right? So I don't want to choose the pi thirds or the pi fourths because I don't know what the R value really would be. So I'm going to pick that. So now I'm looking at 11 pi 6. Okay. So this is a time where I had to choose a different one, right? So when I do that one, this is going to give me 2 minus 4 times the sine of 11 pi 6. What is the sine of 11 pi 6? It is negative what? 1/2. So negative 1/2 times -4 is a positive 2, and 2 plus 2 gives me 4. So I still don't hate B, right? When I do that here, 2 plus 4 times the cosine of 11 pi 6. What's the cosine of 11 pi 6? 3 square roots of 2, right? And so 3 square roots of 2 times 4 is going to be 2 plus 2 square. Wait, what did I say? That didn't come out of my mouth right. Square root of 3 over 2. I have no idea what just came out of my mouth, but it just occurred to me. Is that what I said? 2 square roots of 3 is what I was saying, which, no, I'm sorry. Square root of 3 over 2. I think my brain was ahead of me. Square root of 3 over 2 times 4 is 2 square roots of 3. Yeah, I think I was just thinking way far ahead of myself. Now, is that going to give me 4? No. And here, when I put that, I'm going to get square root of 3 over 2 again, if I can say it right, times 4. Like this is going to have something with square roots also. I don't like that one either. My answer is B. Okay. So there may be times where you need to choose more than one. And again, this specific question, would you have had to do all of that? Absolutely not. But that also shows you why you want to try to eliminate some first if you can. But the answers could have all been negative sign or whatever, and we just have to check them. Okay, we good? I don't think that that's going to happen. I really do think that they will look kind of like this to see if you do know, can you narrow it down between sine and cosine, those sorts of things. And if you can, great. And if you can't, then you've got to go through all this mess. But they won't all be that easy for sure. Okay, so we didn't get very far, but that's okay. I don't want to even start this one right now. I do want to show you something though, because I have a minute or so that I meant to show you this earlier. Yesterday I showed you some of this. That first rows that we did, look at this. If I go from 0 to pi halves, I get half of the 3 petal rows done. If I go all the way to pi, I get the entire thing. Remember it said that they showed you the graph from 0 to 2 pi. And I said they could have had 0 to pi, right? And that's because you only have to do half the circle to get the whole rows. And if you do it again, you're just drawing right back over it. But you don't have to obsess over that if you don't have to do anything with the actual domain. They're just telling you what, and they were nice to put 2 pi and not make things confusing. But it does just take, we only have to go to pi. But it is more than one cycle of that. So anyway, that's that.